So let's get back to exploring this map here. So we've established, for instance, that if you live on this point here, M, this point M here is exactly the same distances away as it is from Forest Avenue as it is from Fresh Pond Road, right? So M here is the same distance like this, right? Now, note that this is not the only point that exists here. Are there other points here that have this property, that they're on the same distance here? We look at this black line here, and remember the black line here represents this border between the purple and the green zones here. So that means if you lie exactly on that point, let's say you call this point here Q. This point Q, this distance from Q to Forest Avenue, and the distance from Q to Fresh Pond Road should be exactly the same here, right? So it should be the same like this here. And let me go ahead and solidify the line, actually. Let me go ahead and, blacken in this line here so we can see it a little bit more. So that point Q appears to be the same distance away from Forest Avenue as Fresh Pond Road. And it seems like any point on this line is going to be the same case as well. We call this point down here R, for instance. From Forest to R to Fresh Pond to R, both of them should still be the same here, right? And then you can have a point S down here, down there, and so on and so forth here. So all these points here, as you can see, are the same distance away. And in this situation here, what we're going to do is we're going to define it in this fashion here. So we can say that a point is equidistant from multiple objects if and only if it's the same distance away from all those objects here, right? And I mean, considering the definition here, considering the word equidistant, this definition makes a hell of a lot of sense, right? You can kind of see this sort of thing here, okay? So we can say that, and now, so if we apply that definition here, we can see that, for instance, that Q, M, R, and S, all these points are equidistant from the two endpoints of this line segment, Forest Avenue and Fresh Pond Road here. Now, if we look at the black line segment, let's look at point M. So this black line here, it's pretty clear that this black line is the midpoint of the segment between Forest and Fresh Pond, right? Now, also note that it appears that this black line here appears to create right angles here. It looks like there are right angles like this here, right here, right here, right here. Looks like there are a bunch of right angles here. So this line here, this black line, this border here, appears to not only be a bisector, but it's a specific type of bisector. It intersects the line, and it's also perpendicular to it at the same time. So this here, we suspect that this is the perpendicular. Oh, I guess I'll go ahead and. So this here, I guess I'll mark this in red. We'll say that this is the perpendicular bisector of the segment here. And since I don't want to give these, I'll just give these names X and Y. We can say that this is the perpendicular bisector of segment X and Y here, okay? So this line, this black line here, is going to act as a perpendicular bisector. And it would seem that every point on that is equidistant here. So basically what we're saying is it true that any point that's on this black line here will be the same distance away from X and Y? So if we look back at Q, that's actually not too hard to show, right? Because if you think about it here, Q, if you look carefully here, you see QXY, like this. Sorry, QXM and QMY, sorry, QXM and QYM, both these are triangles here. If we can show they're congruent, that's great. Now, it's not too hard to show they're congruent here, right? Because we know there's a perpendicular bisector. XM and MY are congruent here. They're both right angles because it's a perpendicular line. So that means we have XMQ and YMQ. Those both work here. And of course, we also have QM being congruent to itself. So we can see that this is our setup here. We can get two congruent triangles here, right? One triangle here and one triangle here. QXM and QYM, both these triangles are identical to one another. They're congruent to each other by side angle side. So therefore it means that the two sides here, QX and QY, are congruent, and therefore it's equidistant. And by the way, note that Q is not any specific point on this line here. I could have done this exact proof with R down here, with S over here. I could have also picked any other line, any other point on this line, and it would work out here as well. So what we have just shown, ladies and gentlemen, is this here. So first off, I'm going to formalize the definition here of the perpendicular bisector. So as you can see here, I formalize that definition. A line or line segment is a perpendicular bisector of a segment if and only if it bisects the segment and is also perpendicular to the segment itself. And then, you know, we basically just did a proof of this particular theorem, but we didn't actually go about showing that. You didn't write this formally, but I trust that you can write this formally on your own. If a point lies on the perpendicular bisector of a segment, it has to be equidistant from the endpoints of that segment. So that's also going to be a really important thing here, okay? And notice that something like this here is not too hard to prove, okay? So that should work out pretty well. So I'd like you to just, again, think about this here, and then we'll move on.